Greetings. In this video, we're going to take a look at finding trig values of any angle. Your first inclination at looking at this problem might be just to type it in your calculator, and you could. In fact, go ahead and do that. Take a minute, make sure you're in degree mode in your calculator, and type in sine 30 and sine 150. What do you notice? Pretty cool, huh? It's the same. They're both 1/2. Now, question is, why? Why are they both equal to 1/2? Well, before we get into that, I'm going to have you stop. We're going to have to shift our thinking a little bit. So we kind of are used to and comfortable with this idea of SOHCAHTOA. That works pretty good when I have right triangles. But if I have 150 degrees, that's a bit of a problem for a triangle. We're going to have to shift to our circle and our x, y, and r definitions. So on the circle, we can see here, we've got a circle. If I zoom in on the circle, in the first quadrant, it works pretty good. So if this is my radius, I'm going to have an x value and a y value. Where's my x coordinate in this picture? Hopefully you're thinking about the x-axis being here, your y-axis being here, and then your x value ends up being this distance from here to here, right? And then my y value is this distance, which ends up being the same as this distance. So we can still kind of connect to the triangle to help us think this through. So if I have theta here, and this is just a quick review, sine theta, y over r, cosine theta, x over r, tangent theta, y over x. And hopefully you're comfortable with it. Because what's going to happen is you're going to get values that don't have a triangle. So take 90 degrees, for instance. When you have theta as 90 degrees, you've got an angle here, angle here. There's no triangle. You're going to have to use this circle. And you're going to have to think of, okay, this is at 0, 1. The sine of 90 then is y over r. That'd be 1 over 1. Which is 1. This works great, even though we don't have a triangle. So, anyway, bit of a side trail, I'm sorry. But we are going to switch over and we're going to use these definitions extensively. So make sure you're comfortable with them and where they came from. Because that's going to help us understand sine of 30 and sine of 150. So kind of like this picture. I'm going to see if I can drag it over there with me. Yeah, I was afraid of that. Give me a second here. I think it would have been easier just to redraw it myself. Definitely a lot of work there to get this picture, but now that I have it, I can use it to my advantage. So, and I'm even going to duplicate one for later. All right, so sine of 30 and sine of 150. The first thing we're going to want to do without our calculators, because some of them you're going to have to not use calculators, is to make our little xy axis and put a circle on it. so that we can use it. Then we need to find 30 degrees. Hopefully you know that this is 0 here. This is 90 here. So if I divide this into thirds, 30 degrees would be right here. So this is 30. Now, if you think about this, 30 degrees, if I know the x value is here, the y value is here, the radius is here. So how big we get to pick. Remember I mentioned about similar triangles, it doesn't matter which one we're looking at. The ratio of the opposite over the hypotenuse, y over r, is going to be the same. So 30, 60, 90 triangles are as easy as 1, 2, square root of 3. Do you remember where to put them? 1 is going to be on the short side, 2 is the hypotenuse, square root of 3 is here. The one thing you want to think about is the positive and negative signs. So in this quadrant, x is square root of 3, y is 1. So the sine of 30 degrees is opposite 1 over the hypotenuse 2. Now let's take a look at this for 150 degrees. Well, where's 150? Well, hopefully you're comfortable with this being 180 degrees. This is 90. So 150 has to be between the two. Where exactly? Well, you're probably thinking, well, 30 degrees back from 180. And you would be exactly right. I want to make it just a little bit higher. Okay, so if you know this is 30 degrees back, and then you're thinking sine is y over r, you're going to think about your y value here, and my radius here. Now, you're probably seeing another 30, 60, 90 triangle, and thinking, okay, 30, 60, 90, this has to be 1, my radius has to be 2, and my x value has to be the square root of 3. You're wrong. It's not the square root of 3. Why? Because we're on the xy plane. The x is negative square root of 3 because we're going to the left. Y is positive. We are going up. So we get negative square root of 3 as my x value, 1 is my y value, and 2 is my r value. So when I go to sine of 150, you see the y value is 1 over the radius, which is 2. Quick note, the radius is always positive. Even if it's down here, the radius will be positive because it's a distance. All right, so let's take a look at this. You'll notice that regardless of whether it was on the 30 degrees in the first quadrant or 150 degrees in the second quadrant, the y value is still the same, and so the sine is the same. So I know there's a lot there, and I explained a lot in there, but this is why we get the same ratios for sine of 30 and sine of 150. So really understanding this unit circle deeply is really important. Understanding that we're looking at x and y values, seeing that we have a y value in the first quadrant that's the same as a y value in the second quadrant is huge. Seeing that the x value in the first quadrant compared to the x value in the second quadrant, same absolute value, but this one in the second quadrant is negative, this one's positive. That makes a big difference. All right, so if you got that and you understand that deeply, I would encourage you to pause the video and go ahead and do the next section on your own. All right. I am going to take a look here. and find the exact value of sine, cosine, and tangent. Remember, what did I say this exact value is keyword for? What does it mean? No decimal approximations or no decimal rounding. Okay, so 1.5 is exact, but if I had a answer in my calculator that went on and on and on, and I rounded to 1.5, that would not be exact. Okay, so that's what's going on there. All right, how are we going to find this without a calculator so we get no decimals? Well, first we got to find 225 on the unit circle. So where is 225 on the unit circle? Well, hopefully you're thinking 0, 90, 180, 270, 360. And so that narrows us in. We're in this quadrant. Where exactly in this quadrant are we? Well, if we just do a little subtraction, 225 minus 180, we see we get 45 degrees past. So that's half of 90. So right about there. So this is going to be 225 degrees. And the question is now, what's my x and my y values here? Hopefully you see that my x value in this quadrant is going to be negative, as well as my y value is negative. So this is going to be a negative number, a negative number. If you think about the reference angle and you think about the triangle, you know this is 45, 45, 90. And so hopefully you remember your ratio is 1, 1, square root of 2. But in this case, these need to be -1, -1, square root of 2. And so in this quadrant, we get -1 for x, -1 for y. Square root of 2 is always, shouldn't say it that way. The hypotenuse is, let me call it a radius instead. The radius here is always positive because it's a length. If I grab a tape measure and I measure this, it's always positive. Nobody's ever -6 feet tall. They're always positive. So now to find sine, cosine, and tangent. Let's go ahead and do this. Sine of 225, cosine of 225, tangent of 225. So sine we know is, do you know the definition on the circle in terms of x, y, and r? Hopefully you're thinking y over r. So my y value is -1, r is square root of 2. Cosine of 225 is x over r. That's also going to be -1 over square root of 2. Tangent, I think this is kind of cool. We'll get y over x, that's -1 over -1, which gives me +1. Now, if you want, you can stop here, or you could rationalize these. If you rationalize them, you get negative square root of 2 over 2, but I'm really fine with you leaving them like this. Ooh, there you go. So, that is part A. Let's take a quick look at part B. -780. We still need to find sine, cosine, and tangent for all of these. Sine of -780, cosine -780, tangent of -780 degrees. So how are we going to do that? Go ahead and try it if you haven't. First thing, we're going to have to find -780 on the circle. Well, I know if I go negative, I'm going backwards. So that's once around. That's twice around. So if I go around twice, I know that's going to give me -720. I need to go a little bit further. From 780 to 720 is 60 more degrees. So I need to go 60 more degrees in this direction. So that's going to put me down here-ish. So that's -780 degrees. I now need to think about my x and my y coordinates here, and my radius. All right, so hopefully if you're thinking, oh, this was 60 degrees, I'm maybe going to erase this. Oops, not that. Just to make it so I can see. I know this is 60 degrees. So I could use any size triangle I want. I'm going to use a 1, 2, square root of 3 triangle. Do you remember where the 1, the 2, and the square root of the 3 goes? The 1 goes here. 2 is the hypotenuse. Square root of 3 is here. But in my picture, I have a problem. Do you see the problem? The problem is my y value should be negative. So x is positive 1. My y value is negative square root of 3. My r is positive 2. Again, even though it's below the x-axis, the radius is a length and is always positive. All right, so now we just need to plug it in. Sine, in terms of x, y, and r, is y over r, so it's negative square root of 3 over 2. Cosine is x over r, 1 over square root of 2. Tangent's y over x, so negative square root of 3 over 1. And there you have it. We have the exact values for sine, cosine, and tangent. Quick review. Key concept is when we're on a circle with our trig functions, we really need to rely on the y, r, and x values. It's going to give us negative answers at times. That's important. It's always also going to help us if we don't have a triangle. Sometimes that will happen. Matter of just drawing your picture, finding exactly where the angle is, finding your reference angle, which is 60 here, 45 here, and then using your ratios that you know. So 60 is 1, 2 square root of 3. 45, 90 is 1, 1 square root of 2. Throwing your negative signs in.